So when we try to access the elements, you can think of it like this. So when you have the first index here will cut the matrix or the two-dimensional array in the first location, and then the second index here will cut the corresponding vector or the one-dimensional array of that index of that matrix, and then the third index here will just give you the element, which here is just the first element in that first vector. Okay. All right. Now we can actually reshape. I mean, we can take a slice of the array. So what is a slice? Now, when we determine the exact index of at each dimension, it will give you just one value in return, right? If you get if you want a range of values, that will give you a slice. Okay, so every location in which you can put an index, you can put a range. And the range looks like this: the start, end, and the step separated by column. And we're already familiar with this format. It's the same in the range function. Okay, so if we didn't specify the start, it will default at 0. Didn't specify the end, it would default at length, and the default of the step is 1. So we can just put the columns and not specify anything. Okay, so if you say one dimension like this, go to the code. So if I go to this one dimension here, and I say print one dimension of just like this, so all the defaults, the 0 and the length and the 1 would apply, and it will give me the entire array. Okay. Okay, if I want to specify a particular range, I can change the default by setting. So if I want 2 elements out of this array, I can specify where to start, where to end, and what's the step. Okay, so it's pretty much, this concept is pretty much similar to the range that we've been working with. Okay, now the same concept apply on the two-dimensional. You don't have to use ranges in all the locations of the indices. You can specify, so you say here, you take in one vector of the two-dimensional, and you take the elements from 1 to 3. Okay, so that's the slicing. And then there is the concept of reshaping. You can change the dimensions or change the shape of the array using the function called reshape. Now, the only restriction here is that the new shape must have the same size. Okay, so you can't reshape it into something that's of different size. So if you have something like this is one-dimensional array, you can turn it into 4 by 3, 2 by 2 by 3, any shape you want, as long as the total size is the same. It's just, and the size is just a multiplication of all the dimensions. Okay, except if you send a negative value to the reshape function, it will flatten the entire array. So it will turn it into a one-dimensional array. So here's an example error. So because the size of the new shape is 4, and we definitely have much more than 4, so we cannot reshape it like this. Okay, so you can reshape it the way you want, as long as you keep the size. If you send a negative value, whether it's -1 or any negative value, it will take the array that you have and flattens it, and that makes it a little bit easier to reshape if you want to keep the order of the elements. Okay, so here we just flatten it into a one dimension and then reshaping it again into 2 by 2 by 3. All right. So that's a general introduction to the yes. You can. Yeah, sorry. It's easier. Yeah. Now you can generate that. There are some nice functions that can generate, and they are very used very heavily with TensorFlow. You can generate pre-populated matrices. So function called ones generate a matrix with all ones or zeros, which is very popular. The ones and the zeros are very much needed in many algorithms. And also you can generate a matrix based on a range. Okay, so these are the basic functionality in NumPy that gets you started with it. Thank you very much.